Hi, everyone. Good evening, good morning, good afternoon, wherever you are. Thanks for joining this Power Pack session. It's an exciting evening here in India. We're going to take a ride through initiatives that are going to drive the next generation of technology evolution, which is going to make 5G reality. We know we've heard a lot of these terms about disaggregation, about virtualization, about open interfaces. Well, what does it all mean overall for the industry? What does it mean for the operator community? And most of all, what does it mean for the consumers? That's essentially what we're going to learn today. And how does open initiatives and standards help codify that and make that journey a reality? And how do operators overall benefit from this evolution of standards that are open with open interfaces? I will, without further ado, hand over to our first speaker, Professor Sachin, who needs no introduction. He's been spearheading some of this from the ground up, and we'll have a couple more keynote speakers right after, and followed by the panel session. So with that, over to you, Professor Katti. Looking forward.
Great, thank you, Rajesh. Let me share my screen.
Sure.
Can you see my screen?
Yes. It's come
up. All right. Great. Thank you for the invitation. I'm delighted to speak today. And as Rajesh mentioned, what I'll be talking about is all of this talk that you might be hearing, even in the popular press, about Open RAN and how that is changing the telecom ecosystem. So a little bit of history before I dive into technology. I'm a faculty at Stanford, as Rajesh mentioned. I'm a professor in the computer science and EE departments. But there's a couple of other hats that are relevant to this conversation. So a few years back, we were doing research at Stanford on how do you bring SDN to the wireless world. So many of you might have heard this term SDN, software-defined networking, and that was a pretty big transformative research that came out of Stanford and really kind of changed the architecture of data center and enterprise networks. And so our thinking was, how do we bring the same kind of programmability and disaggregation to the radio network? And that's when we started what is then called the XRAN Forum in 2016. This was just AT&T, Deutsche Telekom, and SK Telecom, and me and a few other vendors at that time. And that eventually became the Oei Alliance back in 2018, right? So Oei is now a pretty global body. Pretty much every operator and every vendor in the world is now a member of it. And it's really driving the whole ecosystem towards an open and disaggregated network architecture, which I'll talk about today. But humble roots, it actually came out of kind of a graduate student's PhD thesis a few years back. What has been obviously very surprising to me is how quickly things have changed, how quickly things have actually happened. So Oei, as I said, is just 2 years old. In the world of telecommunications, that's nothing, right? That things take a long time before things change in this world. So it has really happened very fast. Obviously, there's geopolitical tailwinds here that are also helping this transformation. We'll take it, right? So whatever helps us open up this network. So what is ORAN, right? So you might be hearing this term, and there's actually a lot of these terms that get kind of bundled in. So let's start by kind of deconstructing that, right? So the first, why was this even started was because the observation was that the radio access network, which is the most expensive piece of the network, right? If you are deploying a 4G or a 5G network, the RAN, the radio access network, is the most expensive one. And it was also closed, and it is still closed to a large extent. So what does closed mean? It's a monolithic network stack, so everything's tightly integrated. And you really only have 3 or 4 maybe now main vendors that are delivering products for deploying these networks today. So very little competition. Even if someone wanted to come and program the network, introduce their own innovation, even if an operator wanted to do it, it was quite cumbersome to do it. It is very slow to bring innovation into this world. So that's really kind of the genesis for why did we start Oei Alliance, which is how do we make this part of the network, which is so important, which is a critical national infrastructure, how do we make it more open? How do we make it such that we get the benefits of the rest of the IT world, which is enjoying the economics of the cloud, right? Both in terms of cost as well as agility in bringing new innovation to the world. How do we bring that to the radio network? So that's really where kind of the thesis was behind starting ORAN at that time. So this word disaggregation, though, is a catch-all term, right? It gets talked about in a variety of contexts. And ORAN itself is pushing disaggregation along several dimensions, and I'll talk about those in a minute. But one of the dimensions that's very important is virtualization. And because this, the idea that virtualization by itself is enough is also talked about. So I want to kind of make sure that's separate. So virtualization, of course, is how do you decouple software from the hardware? How do you run the radio network workload as software on general purpose hardware? And then that allows you to decouple the hardware from the software itself and gives you the economics and agility of the cloud and bring it to the RAM. Right? But virtualization is super important. Alongside that, ORAN is also pushing for other forms of disaggregation that I'll talk about. So let's not confuse open ORAN with just being virtualization. I think you want to do a bit more than just virtualization. So let's dig in, right? So what do I mean when I talk about the current radio access network? Why are they closed, right? So this is a simplified picture of what's happening. Many of you are probably familiar with this term, so pardon me if I'm going into too much detail here. But the first one is the UE, that's the user equipment, that's your phone. And that is talking to the antenna here. And that's the antenna is where the cellular infrastructure starts, right? That's where your network starts. That interface between the infrastructure and the user equipment is well defined. That's what 3GPP does, right? So don't need to get into that, right? So that's, well, it works well. Leave that alone. So what ORAN is really focused on is this gray box underneath. So this gray box is the RAN, right? The radio access network, and it has been historically delivered by a single vendor. And it has a few components, and I'll walk through those in a bit of detail. So the first one is the radio unit. And this is the piece of hardware as well as radio signal processing software that is being deployed at the bottom of the cell tower typically, and it has historically been delivered as proprietary software on proprietary hardware, so highly coupled, right? Then you're connecting that radio unit to the baseband unit, and this is basically the piece of software that's doing the processing of your signals and connecting you to the internet, connecting your phone to the internet. So a pretty important piece of software. Once again, this has been delivered as proprietary software on specialized hardware. So again, tight coupling, and there's not a lot of virtualization or disaggregation that has happened here. And finally, how do you manage all of this complex piece of infrastructure? That's really the management plane, and that's controlling and programming both the radio unit and the baseband unit to configure the network. So what's the point here? The point here is that all these three elements, I've kind of drawn this gray box around it, and it's essentially delivered by one vendor where there's limited programmability, very low flexibility for introducing new services, and it's been historically extremely hard for a new vendor to enter this market. That's been the challenge, right? So, and that's why the supply chain for telecom infrastructure has shrunk over time, to the point where in many countries around the world, a telco really has only one or two vendor options really to deploy a network today, which creates a lot of risk, as you can imagine. In contrast, by the way, the core network, there's been quite a bit of virtualization success already. So the core network is the one at the bottom, that's CN. And there you already see the packet core and many other network elements being deployed as application software on general purpose hardware, right, in a virtualized fashion. So that is, it's not that the telco world has not enjoyed some of the benefits of virtualization, it has, but it's just never penetrated the radio network before. So that's what ORAN is now trying to change, right? And so I like to joke that we are going from this gray world, this on the left, to this rainbow multicolored world on the right, right? That's what we are trying to enable here. And as I was mentioning earlier, it's trying to disaggregate that box, that gray box, along 4 dimensions. And I'll walk through each of these in a minute because they're each equally important. So the first one is what I call radio disaggregation. This is disaggregating the radio unit from the rest of the network via what is called the open fronthaul interface. Now, this actually sounds simple, right? So it's just a piece of hardware, you define an open interface. What is a big deal, right? The reason this matters is twofold. One is the radio unit hardware, the hardware that you put at the bottom of the cell tower, is one of the most significant pieces of the capex for an operator. Depending on who you talk to, between 30 to 60% of the capex goes into this piece, right? So a pretty big chunk of the expense is going there. Second, even more important in my opinion, is that once you deploy something at a cell tower, you really don't want to touch it for 10 years until you really need to upgrade it, right? Because it's a pain to go drive to every cell tower, get trained people to go swap out equipment. So what ends up happening is the things that get deployed once at the cell tower, you just really never change it. So that's why it was super important that this one be open and multi-vendor, because what used to happen before was that the radio unit was from the same vendor. They exposed a proprietary interface, and no one else could connect to that piece of hardware. And so that necessarily implied that whichever vendor you bought the radio unit from, they would have to supply the rest of the software to. So it's super critical that as 5G upgrades happen, especially in India, which is probably where the 5G upgrade is probably coming in the next couple of years or so, it's super important that the operators deploy radio units that expose an open multi-vendor interface like the open fronthaul interface, and that's radio disaggregation. And here, there's been tremendous strides that have already been made over the last couple of years. So several operators around the world, including tier 1 brownfield operators, basically operators that have legacy equipment, that have legacy 4G equipment, they're all requiring and mandating that all of their 5G deployments from vendors have this open fronthaul interface, right? So radio disaggregation is fairly further along. It's really opening up the ecosystem. A lot of new vendors are coming in, right? So that's the first piece. The second one is what I like to call as compute disaggregation, and that really refers to this piece, the DU, the CU. These are the network elements that constitute the 5G service, right? So the DU stands for the distributed unit, the CU stands for the centralized unit. You can tell, very expressive terms. I'm joking, right? That the 3GPP and telco in general tends to be an acronym soup. But what DU and CU really stand for is they are implementing the layer 1 to layer 7 processing of the radio network. So they are the ones actually doing all of the processing of your signals to packets and vice versa. And that's the thing that's connecting you to the internet, eventually your phone, right? So critical piece of software. Compute disaggregation here, what ORAN is driving towards is making sure that this piece of software can either be run virtualized or containerized on general purpose hardware. So you see this picture where I'm trying to show this decoupling between the software and the hardware and use general purpose compute to run this. So this is also actually now taking off. You obviously have heard about Rakuten in Japan, and that has deployed a virtualized radio network for LTE and now going to 5G. Dish in the US is deploying a 5G network that is fully containerized, running on a VMware virtualized platform, and that is running the entire 5G standalone network in a containerized fashion. So these are obviously greenfield examples. Greenfield referring to the fact that neither of them, Rakuten or Dish, had any legacy infrastructure to worry about. So one concern that's always thrown about is this only for new networks? But what about existing networks that are already out there? How can they enjoy the benefits of this? So that's not true. So Verizon recently announced around a month ago that they have now deployed a Samsung RAN solution in a virtualized fashion on Intel silicon, right? So general purpose hardware. And that's what they'll be rolling out as they roll out 5G in the US. So that's a pretty big proof point. So not only do you have new entrants like Rakuten and Dish deploying virtualized and compute disaggregated radio networks, you now have pretty large networks, complex networks like Verizon also going into the compute disaggregated route, which is the virtualized route. So those first two levels of disaggregation have, in my opinion, already have the proof points to give operators around the world confidence that this can be done and should be done. The economics are there, the technology is there, and the long-term architectural benefits are significant. Because if you can disaggregate the compute, that means that you can then upgrade software, you can bring all of the benefits of cloud and management that you could not before in the radio world. Then the last two are where I'd say they are still in trial phases, right? So they are basically the control plane disaggregation that refers to the RIC. And the control plane disaggregation is fundamentally trying to decouple the intelligence from the underlying network elements, from the underlying DU and CU network elements, and run it as applications on top of a control plane platform. So for those of you who are familiar kind of with the SDN world, the idea here was that the RIC would be like an SDN controller, where many of the network management capabilities were delivered as applications on top of this RIC. And the goal really here was that we are seeing a lot of innovation, especially in academia and even startups, that are trying to bring, some wireless optimization technology. It could be a new MIMO processing technology. It could be a new link rate adaptation technology. It could be power tuning, all kinds of stuff, right? The problem was that any such innovation which was focused on one part of the whole wireless ecosystem had almost zero chance of succeeding, because to get their innovation out there, they had to build a whole system. They had to build this whole thing to just put one innovation out there into the market, right? And as you can imagine, that's all next to impossible for a small 10-person startup. So the idea behind control plane disaggregation, behind this RIC, is how do we build a platform that enables an ecosystem of smaller players to deliver just what they're good at, right? That one capability, and they don't have to worry about the rest. And that's really kind of the concept behind the RIC. So that's still ongoing work. There's a lot of active debate, I'll say, in the Oei Alliance around what is the right kind of intelligence to decouple and put on top of this platform. And there are already kind of some trials underway with different operators. So I expect this to happen over the next 18 to 24 months. Last one is management plane disaggregation. We use the term SMO. SMO stands for Service Management and Orchestration here. And just color again. So what is happening here is that you want to drive automation, right? So the challenge as 5G comes along is that you're going to have a lot of radio network points, right? So base stations being deployed. So for example, AT&T alone probably will have on the order of 500,000, 500,000 cells deployed out there, some number like that. And China and India are probably 10 times that size, right? So how do you actually scale the configuration, the deployment, the upgrade, the lifecycle management of such a large number of points, right? And it's really hard to do this in a manual manner, because one, you may not have enough trained people to do it, right? And even if you did, it's extremely cumbersome to program infrastructure that numbers in the millions, right? So SMO is really about how do we design, again, open interfaces that are programmable, that can work with a variety of different vendors' implementations and give you the ability to drive automation in this world, right? And that's the management plane disaggregation. That's the SMO layer. That I think actually, I'd say it will happen even before control plane disaggregation. So there are operators that are now trialing solutions here. You should expect to hear some kind of news about things being deployed in this world in the next 12 months. So I'll just kind of summarize, right? So when you hear the term ORAN, I want you to remember that there are 4 levels of disaggregation that ORAN is driving. It's not any one of these, it's all 4 of these. Obviously, not all 4 of these will be deployed on day one, right? If I were to make a prediction, almost every operator out there is going to deploy disaggregated radio. It just makes sense. It's a lot. There's a clear business case for it. So the radio unit will definitely be disaggregated. Some subset of those operators will then deploy compute disaggregation, which is a virtualized RAN, right? And that also makes sense because the economics are just becoming more and more obvious as Intel and NVIDIA silicon evolves. And then once you do those 2 things, though, you have the luxury of waiting for doing the last 2 things, the control plane and the management plane disaggregation, because they are ultimately then software upgrades, right? They are not hardware upgrades. So ultimately, they become software upgrades. So if an operator gets the first 2 right, which are essentially hardware disaggregations, radio and compute, then the next 2, they can phase in when the technology becomes mature, when the interfaces are fully kind of agreed upon by everyone. And I expect that to happen over the next few years. So that's probably the sequence in which things will happen. Now, ORAN itself, just a bit of an infomercial here. It is now extremely successful over the last couple of years. Every vendor is now a member, and every operator, as far as I can tell, is a member. More than 200 membership companies at this point, and it's now getting to the point where I think there are plug fests that are being announced. There are interoperability. So the point here being that it's not just an architecture and standards definition work now. It's getting to the point where there are products and there are plug fests being organized to make sure that products are interoperable. So we're really seeing products out there that are compliant with these interfaces. So just kind of a little bit on the architecture itself, getting into the details now of the ORAN architecture. And I will kind of spend a few minutes there and then try and kind of wrap up. I don't know how much time I have. Just give me a heads up on time, please, when I need to wrap up. Anyway.
Sure, you can take another 5 minutes or so. Yeah.
5 minutes. All right, sounds good. So already talked about a bunch of these. And once again, I mean, the reason I want to put this out there is not because I want you to remember all of these alphabets, right? So there's a lot of interfaces. The main distinction here is that there are a few things that ORAN itself is introducing, right? So these A1, O1, O2, E2, and Open Fronthaul, these are new things that ORAN is introducing. And then there are interfaces that 3GPP already has specified. So F1, E1, W1, all of these, X2 and XN. So ORAN is, I think one of the questions that gets asked is ORAN competitive to 3GPP? It's not, right? Our ORAN's goal is to, one, flesh out any gaps in 3GPP interfaces. So for example, in these 3GPP interfaces, introduce what are called profiles, because the 3GPP interfaces are not detailed enough to the point that you can ensure vendor interoperability. So ORAN kind of works on adding profiles to those such that you can ensure they're rich enough that you can implement them and have vendor interoperability. And then there are new interfaces where there are new elements. So one is around radio disaggregation. So that's the ORU, that's Open Fronthaul. And then there are the control plane disaggregation. So that's E2. So E2 is for the RIC, and A1 is for the non-real-time RIC. So A1 and E2 are control plane disaggregation interfaces. And then O1 and O2 are the orchestration and management. So this is the management plane disaggregation interfaces. And then there's this architecture called the OCloud, which is basically specifying what is the cloud architecture to use for deploying the radio network. So already talked about ORAN Fronthaul. So this is the RAN disaggregation. A little bit of technical detail here for the radio nuts out there, right? But in what is going on here is that this is the lower layer of the stack, of the radio stack. So the radio is here, and the layer 1 is here, and layer 2, the MAC, starts above. And there's been active debate in the community about what should be run at the radio unit and what should be run in software, potentially in a data center, right? And there are different splits, as they're called, that have been discussed. So ORAN Fronthaul is based on what is called the 7-2 split, right? And basically the things below this line, the 7-2 split, are running in the radio unit, potentially at the cell tower, and the things above are running in software, potentially at a data center. Right, and one way to think about this is that this is a little bit of simplification, but a simple kind of way to remember what the split really is doing is the time domain processing is happening at the radio unit, and the frequency domain processing is running in software at the DU, at the distributed unit. Right. Now there has been active debate on this, and in the context of India, this is an good question to ponder, which is this particular split assumes a certain level of fiber capacity to each tower, right? You still need latencies between the DU and this radio unit of less than 250 microseconds one way, right? And you need pretty high bandwidth on this fronthaul. Now, as many of you will point out to me, this is not always available, especially in deployments like India, which are extremely dense deployments, and you're deploying cell towers at places which do not have fiber. So this split is probably not viable everywhere in the world, right? So, and I think that's where ORAN is actively soliciting input on other splits, right? And so if there are operators or other or vendors in India that want to push a different split for geographies like India, we welcome that. So 7.2 is not set in stone. So this is where I'd encourage the standards body in India to kind of push for other splits, potentially option 6, which is much more friendly on the front haul, and make sure that that's standardized. Or it could be something else, just depending on whatever your requirements are. So that's the reason I wanted to talk about this. 7.2 obviously was pushed initially by Verizon and NTT Docomo. And obviously, given Verizon in the US and NTT Docomo's Japan, the fiber capacity there was quite already there for them to adopt the split. But the larger point is ORAN is an operator-driven body, right? It's driven by the community. It's not that someone is deciding this should be the architecture. So if there's a different split that makes sense in countries like India, we welcome that. Please put forth those proposals. Last one I'll just kind of comment on is the network function virtualization. So that's this cloud piece, right? And all of these network functions are running as software on this. Now, I think the main thing I want to kind of highlight here is that unlike what you might encounter as the cloud, quote unquote cloud from Amazon, Google, or Microsoft, this cloud is a bit different, right? And the reason is that the RAN software that's running here, the network functions that's running here, have pretty stringent latency requirements. So they need to run like in a real-time fashion. So the cloud cannot introduce too much latency variation. And two, that they need to support acceleration via different hardware options. So it's not just that you're running Intel CPUs. You may need to run GPUs and FPGAs. So the cloud needs to be able to virtualize different forms of compute hardware, not just x86 CPUs. So that's where there is active work, and I think there's a lot of innovation happening here that will come to light in the next year or so on how you are extending this notion of a cloud, of a hypervisor, to be able to handle both real-time workloads as well as acceleration like GPUs and FPGAs that are now coming on board with NVIDIA announcing support for RAN workloads and so on. And this really leads to that ultimate vision, which I think a lot of operators aspire to, which is that I can now build a consistent infrastructure end-to-end, right, from my core, edge, RAN, and to the private network, to the enterprise network, and have essentially think of the telco network end-to-end as a piece of software that's running on a horizontal infrastructure, right? So the RAN was the big holdup, right? Previously, the RAN was this vertical integrated system, even though the rest of the network was getting horizontalized. Now you're getting to the point where you essentially, the operator now first chooses a cloud infrastructure, deploys it end-to-end, and then picks and chooses different vendors' implementations for different network functions as quote-unquote apps that they would deploy on top of this. And then they can drive cloud-scale automation and operations, assurance, and analytics, again, in an end-to-end multi-vendor fashion, right? So that's the end goal. That's the vision that we all want to get to, which is just like you can go to AWS and pick and choose a different database, a different messaging service, a different file system, and build your application by stitching these things together. An operator should be able to go to a similar catalog and pick and choose a vendor for the DU, a vendor for the packet gateway, a vendor for the MME, and just stitch them together on top of their cloud, right? Obviously, I'm simplifying things here, but that's the end goal that we want to get to, such that it becomes super simple to stitch together new services, new network deployments, add new capabilities than it is today, which takes months to years to add any new capability into this telco network. So I'll wrap up, probably go to the end here. So I kind of want to summarize, right? So there's few benefits here. So one is that we want a disaggregated and programmable RAN. And so to really drive modularity, that reduces the barrier to entry for smaller vendors, right? Because we want to get to a point where they can deliver smaller specialized functions instead of giant stacks, and therefore make it feasible to get them there. And this reducing the barrier to entry, enabling new entrants is what will eventually drive a multi-vendor ecosystem that leads to increased competition, diversifies the supply chain, and get to a point where an operator is able to choose best-in-class vendor for each network function rather than be locked into a particular vendor's implementation end-to-end, right? And this ultimately leads to more innovation and more agility in how new services. So I think the way I think about this is our first job at the Oei Alliance is to drive modularity in the architecture. Modularity leads to reduced barriers of entry for newer entrants. That leads to increased competition and a diversified supply chain. And that eventually leads to more innovation and agility into the whole network infrastructure. So these have cascading effects, but it all stems from clear architectural thinking that drives modularity in the infrastructure. And a big success case here is what is happening on virtualized RAN, right? So which is that there's now both tier 1 greenfield as well as brownfield deployments that have embraced and are going all in on deploying 5G in a virtualized fashion, in a containerized fashion, and really try and bring cloud economics and agility to the RAN, right? So use off-the-shelf hardware, drive down hardware costs, and then be able to kind of automate the management and the programming of these network functions using cloud-native tools that really leads to lower operational costs, right? And as I said, the big kind of hidden benefit of such a deployment is that it gives you flexibility for the future as other kinds of disaggregation comes along. The control plane and management plane disaggregation, as it comes along and becomes mature, if you're actually deployed a virtualized RAN on general purpose hardware, it's much easier to swap out or upgrade the software to add these new capabilities than it was before. So with that, I'm going to stop. Happy to take any questions.
Thank you, Professor Katti. I think that was a masterclass in disaggregation and virtualized platforms. And I think it should set a lot of minds thinking about how the journey towards cloud native and how that can benefit 5G. So I think we may, in the interest of time, we'll probably just take a couple of questions and maybe move on to the next session. I think the one question that was asked is...
sorry to interrupt. In the meantime, I'd request Mr. Sachin to close the screen share so that we can see you all on video.
Sure. Yeah, I think one of the questions was about can O-RAN splits also help in the small cell space, or is it just a macro radio?
Yes, so as I was mentioning on the splits slide, so initially it was driven for the macro by Verizon and NTT Docomo. This was the option 7 to split. Recently, work has already started on the option 6 split, right? So this is the NFAPI split for small cells, and to make sure that that is standardized to a level of detail that can be used by multi-vendor implementations. So absolutely. As I said, if there's a different split that makes sense for different geographies, we welcome that, right? So it's not focused only on the macro.
Sure. And I think the question on fiber or the lack of fiber infrastructure in India, there was a question around how does that impact the overall disaggregation? Because now you're geographically sort of developing splits for certain conditions or deployment modes, and how does that help with the overall economies of scale globally from a global perspective? Yeah.
No, good question. So I think even if you do not have the front haul, right, and if you have to deploy the DU at the cell site because you do not have the front haul, a 7 to split is still useful because that means you can still buy the radio unit from someone else and buy the DU from someone else, right? So I don't want to say that the 7 to split is only useful if you're running CRAN. 7 to split is extremely useful because you're still disaggregating the radio unit there. The second thing I'll say is many of the deployments, even Dish for that matter, for example, it's not that there is 100% fiber coverage everywhere in the US. There is still be that last 10% that's not going to have enough fiber. So what's happening there is that the virtualized DU is being deployed at the cell tower itself. So there is general purpose servers that are being deployed at the bottom of the cell tower. And again, you're running the VDU software as a virtual instance on top of this server that's running at the bottom of the cell tower. So you can get the benefits of virtualization in the cloud extended all the way to the cell tower. It does not have to stop at the CRAN data center, right? So you can run essentially even the things running at the cell tower as part of a Kubernetes cluster and get the same benefits of virtualization. So long story short, I don't think the lack of fiber stops you from getting the benefits of disaggregation, both on the radio as well as on the compute side. It's a little bit more challenging because availability is going to be more challenging, right? You cannot have a lot of redundancy when you're deploying at the top at the cell tower, but
Sure.
you still get a lot of the benefits of the virtualization.
Great, wonderful. Thank you, Professor Katti. I wish we could go on, but we just have to run this as a show. So, but thanks again for your time. And I know it's early for you on the West Coast. I appreciate your time and the time you've taken to put this together. So really appreciate that. With that, let's move on to the next keynote speaker, Professor Raymond Knopp. He is from Eurecom in France. He's going to take us forward in this journey towards cloud-native 5G, how open air interfaces can help us get there. So over to you, Professor Knopp.
Okay, thank you very much. Let me just set up my screen share. Hello, there seems to be an issue here.
Okay.
Yes.
RK, do you want to drive it from our side?
Yes. Sir, may I know what's the issue, sir? You're not able to find the share screen?
No, it's not that. It's what happened when we were doing the test earlier. It crashes my Chrome. It didn't do this last week, but it's doing this today.
All right. Okay, Nivedita, do you like to share the screen? Have you given your PPT to the team, sir?
You can. Yeah, I sent the presentation to Nivedita.
All right.
Yeah, I can present. Yeah.
Great. All right, Raymond, we'll share the screen for you, and you can continue.
Yeah, it's up now, Professor Raymond. Yeah. You may start now. The presentation is up now. Yeah.
I think he's in a different screen. Professor Raymond, can you see the screen? Or have you gone to some other tab in the Chrome? Professor Raymond, can you hear us? Niveta, if you don't mind, can you please stop the screen for a while so that I can bring him on Spotlight and we'll check with him. Yes, sir. Now you can guide him, sir. Rajesh, sir, probably you can talk to him.
Yeah. So can you hear me, Professor Raymond? Hello. Can you hear? I think we have lost it.
His connection is lost.
Yeah. So should we switch with Manish and then come back to him, or how do you want to do it?
I think we can switch. Should not be any problem.
Sure.
I can start my PPT. So.
Sure. Great. All right. So this is we need 5G. So we're still working on it. So yeah, thanks Manish. Thanks for jumping in. Well, we fixed the technical glitches on Professor Knopp's connectivity. So Manish, yeah, I'll just let you get Manish again. He heads R&D function at Airtel, and he's going to. He's our other keynote speaker who's going to talk about how the initiatives in India are firming up with regard to open initiatives driven by TSDSI. So please go ahead. Yeah.
Sure. Thank you. Nivedita, if you can share the screen. So hello, everybody. I would like you to, in next 10 minutes, take you through the initiative that TSDSI is driving, and with respect to, how do we, build an ecosystem in India, which is focused on bringing up the open source products, open source tools which can help our journey towards the 5G a lot more enriching, innovative, and rewarding for the companies, both from the vendor, startups, and the operator perspective, but as well as from the perspective of academia, from the freelance contributors who can do a lot of innovative stuff to be able to and bring that out into open and into the deployment mode. So let me take you through that journey that TSDSI has instituted. So can we go to the next slide, Nivedita? So very simply, what the objectives of setting up this initiative, and the way TSDSI is doing it is in the form of setting up a task force, which a bunch of companies are contributing towards. The task force is set a few objectives, which are focusing on 5G as the key technology, right? And we all understand, right, the telco side, the next big technology movement or upgrade that we're looking at is 5G. Thankfully, we have time on our hand due to a variety of reasons. And we would probably see some of the deployments coming into India probably sometime next year, depending upon how the government moves the auctions. But that gives us enough time to be able to allow this ecosystem to flourish and make sure that we have a lot more innovative solutions available for the operators to choose from when they get to that stage. How we want to do it is to be able to leverage the existing open source components, right, that are already there. People have been working on them for a significant amount of time, and then accelerate that towards the requirements which are tailored for India, for the innovations which are specific for India. What it can essentially do for us is it can enable the smaller companies and startups to focus and contribute on specific areas, right? And we heard from Professor Sachin Katti just now that when you do things in an open manner, it allows a lot more innovation and a lot more smaller companies to come into the play and be able to contribute. Another key objective that we are driving is that when we build this open source ecosystem and choose a lot of open technologies to deploy, we would certainly feel the need of interoperating those tools with the rest of the world, right, for the rest of the infrastructure that exists. And that will open up a lot of opportunity for TSDSI to drive the standardization efforts across different set of bodies and in collaboration with the rest of the industry. So that's the sort of the objectives with which the task force has been formed. Can we go to the next slide? Next slide, yeah. So if we really look at the 5G infrastructure, there's too much of detail. Let's not worry too much about it. We just focus on the 3 bullets at the bottom. The whole network is, the 5G network, you can split into 3 different parts: access, transport, and applications, right? So if we really look at what Oei Alliance is doing, it is disaggregating, and that disaggregation is helping a certain part of the network already, right? So if you really look at what we call the access part of the network, will really get benefited by what the Oei Alliance is doing, and we will look into it as to how we are going to leverage the activities there. Then the other part of the network that needs to really open up is onto the transport side, and there is significant amount of work that has been happening in that area as well. That domain is directly benefiting from the work that has been done into the what we call the SDNization, softwareization of the transport IP networks, right? That has been done for the data centers. But a lot of that work can actually benefit the transport and the IP network that actually is utilized by the telcos. And then the third part of the network infrastructure is the application layer, right? Which encompasses the core network as well. But again, right, there is work to be done, and then that layer, though, is not purely, from the network structure perspective, falling into the core network, but there's a part of network process that we need to follows what happens into the application world. So that's how we have divided the entire network infrastructure into the three categories: access, transport, and applications. We go to the next slide. And then, if you really look at the whole ecosystem that exists today around these three segments, there's a large number of open source projects that have been going on all over the world, in wireline, in wireless, on transport side of things, within the management layer, what we talked about at the orchestration layer, and then also onto the lot of core functions that that goes into the 5G network. So this is the setup. This is the world that we have to choose from, and then adopt to be able to build into something that we can, customize or bring a lot more innovation from India perspective. We can pick up projects from this. So it's not an easy task for us to be able to figure out what's the right thing or what the right sort of projects that we should actually work on. So to be able to make sense out of this, we have set up 3 sub-teams under this task force that we have constituted. Can we go to the next slide? And the process that we have defined for these 3 sub-teams is fundamentally to assemble a group of domain experts from all sorts of ecosystem players, OEMs, carriers, academia, freelancers. We bring crack team of domain experts in each of these 3 domains that we define, and do a few things, right? First of all, evaluate what options that exist in front of us. What's the sort of maturity that they are at, and what experiences that we want to define for them. Then select the best of breed options, and then define what's missing from them. Now, what's missing from them has to be done from the perspective of the market that you're trying to create access into. And we take 5G and India as the key 2 market scenarios, compared to which, in that environment, we are going to find what the missing pieces are. And then build a model for aligning the contributions and harmonizing with the global roadmap. Each of these projects, open source projects, have their own roadmaps that they've been sticking to. How do we basically then fork out and then create specific contributions from the India requirement perspective, and then also guide this team and create a framework for us to be able to handle what the IPR treatment of the contribution has to be, and what sort of licensing and other things that we need to be able to adhere to. So it's a little complex task, I must say, to be able to make a lot of sense out of this. So I must say that we have started and we have created certain sub teams which are focusing on each of the subgroups. We're inviting more and more people to join and make sure that we have all the right set of expertise to be able to give us the right direction. The next steps that we ask these teams to do is to define the structure of these teams, set up a governance model, set up an operating model, we're going to look for what sort of financial sources that we can tap into to be able to fund these activities. And then, most important part of this task force is to be able to evangelize. How do we get this open source to be adopted into different activities, including the commercial networks that operators would be deploying or the enterprise might be deploying. Go to the next slide, please. So the three sub-teams that we talked about in the access, transport, and application domains. And then we have also done a little bit of definition of what each of these three sub-teams would focus on, right? It is not entirely possible for these teams to be able to do everything that is needed. But again, the focus is what's more important, what's most important, and where the contributions will make the most impact is what these teams are trying to figure out. We have a lot of participation from the industry already. A lot of companies which have already come forward to be able to contribute. And we are really looking to expand the reach of these contributions and these participations from the rest of the industry who are already not part of this contributions right now. We go to the next slide. We sort of put together a little bit of what we call a sustainable or virtuous model for building the innovation through the open source development, right? We're saying that let's think what is India's specific use cases, what the India specific requirements are. Once we choose the open source components, start to bring in a little bit of contribution into those projects and integrate them, align them to the standards, right? We really do not want to create anything which is not aligned to the standards globally accepted, right? So we align them, all the contribution to the standards, and then take them to the TSPs, right? In India, we have opportunity with all the operators to basically go and try these solutions out, and then create basic reference code which you can go back and contribute into the community, and then and then keep this cycle going, right? So that's the sort of model that we intend to follow when it comes to building this companies. You go to the next slide. A little bit of details of how each of these teams have made some of the shortlisting onto the project that they want to focus on. So, for example, on the software side, the teams have shortlisted the RAN software to be looked at, and they've been looking at what sort of contributions are available. For example, ORAN Alliance has got an open source work group going on, which there is significant amount of contribution that has been happening. They have made a release very recently, and there is another release scheduled to come out from there. So we're saying that how do we basically adopt that code, open source code, and then build on top of it. Also looking at the cloud infrastructure to see what's the right sort of cloud infra that we need, as we heard in the previous talk, right? Virtualization is the key aspect of disaggregation, and how do we basically build a horizontal cloud which allows us to run the sort of RAN side of components with the strict latency and the bandwidth requirements. And then there are hardware innovations that we are looking at. There are companies which are building a lot of standard hardware, which they are contributing back to the ORAN Alliance, for example, and saying that this could be produced by a large number of hardware partners, and then they can be adopted. The hardware connotation here is, what Professor Sachin Katti was alluding to is, in a country like India, where the fiber to the site is very, very scarce, we do need a physical hardware sitting at the site to host the DU function, and those hardware are usually again driven by the standard architectures, but the bunch of companies which are contributing their designs into the open source, and they can be productized and are produced in large numbers, right? And then collaborate with community, right? We know there are already the projects that are going on. There are standard bodies that are driving some of these initiatives. We need to be able to make sure that we adhere to this boundary conditions of working with these standard bodies to be able to bring the whole solution out. So if we go to the next slide, you'll see the transport subteam has got the similar set of projects identified, which they are investigating from the gap analysis perspective. And again, right there too, the software and hardware both projects are being looked at. And if we go and look at the third, next slide please, the subteam's work, they are looking at how do we basically utilize the RIC framework that is being defined from the network perspective at one end. On the other end, we are also looking at what's the management frame, orchestration layer solutions that are available that we can look at as well. So from the 5G perspective, pretty much covering every element of solution. And we really need to see, we need to be very pragmatic about, some of these will be successful, some of them will not be. As long as we can, create a wave of contributions into these projects specific to the solutions that we're looking for, I think we would be doing our job well. So if we go to the next slide, what outcome that we are really looking at is, how can we get open and interoperable solutions over a standard interface working on the open source components. Customized and dimensioned for India specific use cases is important because India itself has got a huge amount of specificity in the network and the way our requirements and the way our economics work. So we do need to pay attention to that as to how we want to bring this out. Open hardware and software, it basically enhances the opportunities for doing a lot of innovation in India, make in India, build in India, manufacture in India. That's another stimulant that we're looking at bringing in. Startups really get a major boost if they start to work from a base rather than starting from scratch, and then get the market access. That's one of the key pain point for the startups. And if we can create this ecosystem and every player in the ecosystem plays its part well, this will basically enable the market access as well. And eventually, we're all looking to bring down the total cost of ownership for the infrastructure, and it is driven simply by the fact that we have the highest amount of data usage in the country at the lowest possible ARPUs anywhere in the world. So those challenges we are looking to solve using this task force initiatives. So that's all that I had to talk to all of you about, and I really encourage all the companies who are participating on this to really come forward and volunteer for your own contribution to the initiative.
Thank you, Manish. That was fantastic. It's great to see a broad ecosystem of partners come along, and what you've achieved in a very, very short time frame. You and Dr. Indra Gopal have spearheaded this through TSDSI. It's phenomenal what has been achieved, the overall framework, etc. So really, I mean, you touched upon all the points about democratization, meeting the price points that India needs and the use cases that are very specific to India. So yeah, we're it's great to see that we've come along this far. So yeah, with that, maybe if we can maybe switch to Professor Knopp. I think we have him back now. Oh, yep, we'll see you there. Yes. And I think Nivedita, you're going to drive his presentation, correct?
Yeah, I think that's the safest route.
Okay, great. Yeah, your presentation is up now. Please. Yeah, thank you.
Okay, thank you. If you can go to the first slide, please. Okay, so let me just give you a brief introduction to who I am. So I'm a professor in communication systems at an institute called Eurecom. Eurecom is in the south of France. You can see the picture there of our campus. And I'm also, I do have another hat. I am president of the Open Air Interface Software Alliance, which I'll talk a bit about in a few minutes. And from a purely technical perspective, my main area of expertise is really in radio access networks. Okay, so if you can go to the next slide, please. So before I start to talk about the use of Open Air Interface for prototyping cloud-native 5G networks, I'd just like to highlight the fact that a lot of the work that we're doing at Eurecom and in Open Air Interface are with different people, and I'd like to acknowledge the people that I've listed here, from colleagues from Eurecom, from the Open Air Interface Software Alliance, from a team at Red Hat that we work very closely with, and also from some colleagues at Orange Labs in France. So in my talk, I'll give you a brief overview of what Open Air Interface is today and where we're going a little bit. And then I will dive into something more directly related to the work at Eurecom, which is the construction of a 5G test site, which is there really to test some of the innovations we're looking at in Open Air Interface, and work with some of our partners like at Red Hat at putting together some prototyping equipment so that we can innovate and test some of the ideas that we heard in Sachin's presentation earlier, particularly related to NFV architecture and coupling that with radio hardware, and really applications for prototyping cloud-native solutions for 5G. So we heard a lot about that in the previous two talks, and you'll hear a bit more now in my talk about what we're doing with Open Air Interface in this area. So if you can go to the next slide, please. Okay, first of all, Open Air Interface and some of its friends. As we heard in the first talk, now in industry, it's very well known that you can put the basic radio access processing of a 4G E node B or a 5G G node B, and similarly the majority of the software, if we take away the switching components from the core network, whether it's a 4G or a 5G core network, in a commodity x86 hardware box. And in fact, even major vendors today adopt this approach. If you were to look at some of the solutions from Nokia, sometimes when you look at the racks, they're basically using the equivalent of a Dell server, where they've replaced the Dell logo with a Nokia logo, but under the hood, it is basically a Dell server. Of course, there are also accelerators there that are there to do certain parts of the radio access network in a more efficient manner, a power efficient manner. But if now we consider the types of software that what I would call run-of-the-mill users are using to do prototyping, there are different solutions. There is one very excellent solution from a French company. It's not an open source solution, but it is a software solution that runs on x86 from a company called Amarisoft, which is a closed and commercial solution, but very, very high quality software. You have solutions like what we promote in Open Air Interface, which is open source, and in addition to being open source, it is something I would call 3GPP friendly because of its licensing. You have some of the software that is inside the ORAN software community, which is partially open source. Not all of the radio access network is open source, but it is also what I would characterize as something being 3GPP friendly from a licensing standpoint. And then you have other solutions like SRS LTE or OpenLTE, which today are 4G solutions. They don't, as far as I know, they don't include 5G components. And those I would actually characterize as being 3GPP unfriendly because of their licensing. It is not something that is necessarily amenable to putting together a community, and certainly not a community with people that work in the 3GPP space. Now, because of all of this, there is definitely the emergence of what you could call radio hackers and development and user communities that are experimenting with 3GPP software implementations. Now, in some way, this is a way to democratize radio access through open source software and open hardware, which we heard in the previous talks as well. So if you can go to the next slide, please. So a little bit about the Oei Alliance. This was essentially an endowment fund. You have the term there in French, a fonds de dotation, which was founded in 2014. I should say that initially this was really a research objective. It was something that Eurecom was using to strengthen its relation with industry and 3GPP, but from a perspective of furthering its research. And today we have 3GPP strategic members, which are both users and contributors, that are there to essentially help us motivate the community to contribute to this software. And we have many associate members from industry and academia, including quite a few academic members at this point from India that are quite active in our community as well. Which is there to control the continuous integration, continuous deployment. Also to manage the community, building of the community, and industry relations. One thing I can add here is a very recent initiative inside of Open Air Interface. We founded two industry-funded projects now on the 5G RAN and 5G core, which are basically there to accelerate the availability and stability of the 5G standalone solution, and also provide a reference architecture for the 3GPP 5G core. And today, the version 1 of the 5G core components is already available in open source and can be deployed in some virtualization frameworks. So if you go to the next slide, please. Okay, this is just a picture of the current strategic members that we have. And these are the main drivers, if you like, of from an industry perspective of Open Air Interface. What you can see, it is actually quite heavy with US companies, with Qualcomm, Facebook, InterDigital, and also the Power Office, which is a research entity in the United States. So today we are quite supported by US initiatives, but we also have a very strong partner in Japan, which is Fujitsu, and of course the national operator in France at Orange. So it's a small group, but they are all motivated in pushing Open Air Interface to the next level. So if you can go on to the next slide, please. Okay, so in terms of technologies and hardware that you can use to run Open Air Interface software, here I list the 3GPP technologies that we have. Today we do have 5G solutions both for RAN and core, and which can be derived in the RU, the DU, and the CU node functions that Sachin was mentioning before. And we also have the 4G equivalents for LTE. Today, the software will run on commercially available radio frequency equipment and also generic computing equipment. So by commercially available, I mean the entire series of National Instruments Universal Software Radio peripherals, which can be combined with home integrated radio frequency functions I'll show in a second. But we actually also do have some solutions based on commercial radio units that implement different front-haul protocols, including an EC3 variant, but also now, more recently, something that is getting in line with the ORAN 7.2 split that was mentioned earlier by Sachin. Okay, so we can continue, please, the next slide. Okay, so if now I deviate a little bit towards the cloud-native RAN and core components. So we heard in the previous presentation about some of the open source technologies that are out there for deploying software on cloud-native solutions. We embarked with some partners at Red Hat and also in the Linux Foundation in the context of the OPNFV framework at deriving a version of Open Air Interface, both the radio access network and the core network components under a Kubernetes cluster orchestration framework. So today we have a public GitHub called Open Air Interface K8S, which was something co-developed with Red Hat. And this is primarily targeting Red Hat's version of Kubernetes called OpenShift. Now, strictly speaking, there are other members today that are deriving more generic versions of this. But today, in our platforms, we're running this with the Red Hat OpenShift environment, primarily because of real-time constraints. What's interesting, though, is anybody can replicate this deployment framework if they have the proper hardware. And a lot of the work that was done in OPNFV was also providing the basic blueprints so that you could build clusters that are using this. To my knowledge, today there are 2 clusters that are using this development from Open Air Interface. Our own in Europe, and a few other smaller ones in Europe as well. But what I would constitute as a fairly large cluster is ours, and another one now that is being developed in Montreal by a company called Colume Networks, who are also using this framework. For me, the main challenges here in making a cloud-native RAN and core from a purely technical perspective, number one is, of course, is the real-time processing. Getting real-time radio network signal processing running on a Kubernetes cluster is a major challenge. And one of the reasons we are collaborating with Red Hat is primarily for that. The other major challenge is user plane optimizations. So when we talk of protocols like DPDK that are used in front haul networks and also in the user plane of the core network, this is a trick to get that to work properly in a cloud-native fashion. And the third one is the integration with the automation framework, for instance, ONAP, which is something that we are doing today in Open Air Interface as well. So if you can switch now to the next slide, please. Please, the next one. I've already said this more or less verbally. Okay, if I talk a little bit about our experimental site, it's 2 slides afterwards. I'm sorry, if you can advance a few slides. I think you went back.
Nivedita, can you move forward 2 slides?
And one more, yes. One. Okay. No, that was too far. I'm sorry.
I think there's a delay. Yeah.
Yes. Okay. The site at Eurecom, we call it the Open 5G Lab, and basically what it is an indoor and outdoor deployment of 5G new radio units, and also there is functionality for LTE and more basic LTE as well. So you can see here a picture of some of the equipment that is deployed. You'll see a more accurate picture in a moment. But basically, we've deployed a test network which is connected to our cloud infrastructure in our building in order to test real time on an experimental network. So, if you go to the next slide, please. Basically, this is another view of the roof of our building, and what type of hardware is under the hood in this case. This is let's say a homemade radio unit for 3.5 gigahertz. It drives up to 4 50 megahertz channels with a single USRP device. In the rack that you see there up on the roof, there are actually 2 N310 devices from National Instruments and driving 8 3.5 gigahertz antennas on the roof. So this is an example for essentially for prototype equipment that you can use in conjunction with Open Air Interface. And this is something that was built by our team at Eurecom, but that can be replicated by anybody. If you continue, please. We're also able to work with different radio units, which I mentioned earlier. Some that can be done use the ECPRE protocol, actually a split 8 with ECPRE. And yet another one from an Irish company called Benetel that provides a unit that can implement let's say a pre-standardized. It's not fully compliant to ORAN specifications, but it does use the 7-2 split. These are both Ethernet-based frontals that can be let's call them white box solutions for doing a standard interconnection with an off-the-shelf switching fabric, which is what we have at Eurecom. These are typically higher power solutions than what you would get from something you can build from National Instruments equipment. Definitely less generic or flexible, but they're a complete product which are ready for deployment in specific bands. Now, today we have these equipment actually running in our lab with Open Air Interface. It's not something that most people in the community have access to other than the companies that are working with us. But this is an example of how you can use, let's say, more generic equipment with open source software. If you go to the next slide, please. This is yet another example of hardware that can be used. This is a radio unit, prototype radio unit that was developed by one of our partners in the United States, interdigital, which operates up in the millimeter wave bands. And this is also something that can be directly interconnected with some of the USRPs from National Instruments in order to provide a solution that'll work with up to 100 or even 200, although we haven't tested that yet, up to 200 megahertz of bandwidth with an off-the-shelf radio that you can purchase from National Instruments. If you can go to the next slide, please. And so this is in a nutshell, the computing and switching fabric that we have at Eurecom. And basically, it consists of standard off-the-shelf terabit switches from a company called EdgeCore. Today, we have deployed 3 switches like this, which is our basic switching fabric, on top of a bunch of generic x86 servers, on which we've deployed the Red Hat OpenShift framework, which serves as our basic compute and switching fabric. So if you can go to the next slide, please. So if I talk a little bit more about the derivative for Kubernetes of the Open Interface Running Core, this is a cloud-native implementation that targets OpenShift, but can be generalized for other more generic Kubernetes frameworks. And it's all publicly available, as I mentioned before. Today, we have also finalized the integration with ONAP Frankfurt. And this is done in the context of a French project called 5G Eve. And today, the software that you find on the GitHub repository is ready for deployment and automation via ONAP. So this is something that is very new and is being tested. There will be a webinar soon on how people can replicate this setting as well. So I'll talk quickly in terms of pictures now of the 2 types of deployments that we can show with Open Interface Kubernetes. This is a picture of what we have deployed and running today in our cluster. You can see on the left you have 2 radio units, a 5G radio unit and a 4G radio unit with the fronthaul protocol that's being used. It's different in both cases. And then on the left-hand side, you see 2 what we can call hard-time, real-time worker pods. These implement a monolithic version of the 4G and 5G radio access devices, basically the eNodeBs and the gNodeBs, in a monolithic fashion inside Kubernetes. On the right-hand side, you have 4 elements of the core network, which are also deployed on the same cluster, but in something you can call a soft real-time configuration. So the left-hand side, those are hard real-time Kubernetes pods, and the right-hand side are soft real-time. But this is a complete 4G, 5G non-standalone network running inside of Kubernetes OpenShift. Okay, if you can switch to the next slide, please. Now, if we now go back and make a link with Sachin's presentation earlier about disaggregating the network. Inside one of our projects, what we are showing with our partners Orange, in particular Orange, is how we can use Open Interface now to disaggregate the network, where you have all of the control plane functionality at a remote location, in this case 1,000 kilometers away from Eurecom in Paris. And we have the user plane in Sophia Antipolis on our site. So if we now switch to the next slide, you'll see how the network changes slightly.
Professor Knopp, sorry to interrupt, but maybe if you can wrap it up in about 5 minutes.
Yes, it's finished in less than 5 minutes at this point. So the way the network evolves in this case is the hard real-time component on the left stays essentially the same, but it's only a subset of the entities of the eNodeB and gNodeB, what you can call the DU, and potentially also the user plane function of the CU. That could also be in the local location if you want to have it. If you want to have a breakout network, and similarly for the gNodeB, it would only have the DU and the CU user plane function locally with the radio equipment. But in the remote location, in the red block in the middle, that's where you have the control plane functions of the both the RAN and the core network. And finally, the user plane function of the core network could also be local. If you want to have a local connection to a high-speed link to whatever service architecture you're using, that would be feasible also. But what's interesting about this is the same cluster orchestration. So basically what happens is you add a couple of worker nodes at the remote location, and you have them orchestrated by the same cluster orchestrator, in this case OpenShift. So it shows with the same hardware, you can completely disaggregate the network and accommodate a remote location more or less on the fly. That is what we will try and show next year, is how you on the fly can reconfigure this network using configurations that are actually automated by ONAP on top. So if we go to the next slide, please. So to conclude, I gave a general overview here of what we have today in Open Air Interface. And provided an overview of the tools that we provide to be able to prototype cloud-native 5G networks. So in terms of the types of hardware, the compute, and the radio, the way you can target this for cluster orchestration frameworks like Kubernetes or OpenShift, and how you can do this in both a local, so a private 4G, 5G use case, or something that is more geographically disaggregated when it comes to the user plane and control plane functions of the RAN and core network. So what is upcoming now here is the full RAN and core integration with ONAP. That is really underway. In fact, this week we have a key meeting with our partners at Orange to finalize that integration. And we will start to build the disaggregated version, as I showed you, to show that this can function over long links. The third upcoming integration is also the bringing the ORAN E2 interface, which Sachin talked about earlier, and some RIC developments that are coming from partners that we're working with in some of our projects. Strictly speaking, today the E2 interface actually does exist in Open Air Interface. It was developed by one of our of the Oei Alliance, so that could actually not be distributed alongside Open Air Interface software for the moment. My main takeaway here is everything that we're doing in the context of Open Air Interface is open. And it's actually available to reproduce in your labs. Even many of the deployment scripts to be able to take it, as I described, and put that on a Kubernetes network is available today. And you know that is something that we're encouraging many of our partners to start looking at and contributing to. So I'll stop there, and I'd be happy to take any questions if there are any.
Thanks, Professor Knopp. I'm looking at the questions here. I know that we've sort of overshot the time. I don't see any that are pending. So I think in the interest of time, maybe we go into the panel, and then maybe folks can become more interactive and ask their questions there. So I think that's phenomenal. 3 keynote speakers. Thank you so much for covering a vast ground on open initiatives that are going to drive 5G networks of the future. With that, what I would like to do is introduce Dr. Inder Gopal. He's going to be the moderator for the panel. Professor Katti and Professor Knopp are going to join Gilad Debabrata Das, Professor Debabrata Das, and Professor Ravikant Basumarthy. Or actually, he's from Altran, Mr. Basumarthy from Altran, in an exciting panel. So in the interest of time, I'll just maybe bring the panel to the stage. Yeah. Thank you.